Owls are famous for being incredible night hunters. Their amazing eyesight allows them to spot prey in the darkness and swoop down on them from above. But an owl's vision is special for another reason as well. When you look at an owl during the day, its eyes seem to be stuck in a permanent state of half-open surprise. And this isn't just for show. Unlike most birds, owls' eyes aren't able to dilate and constrict much during the day. They're basically stuck wide open, and that causes problems. So today we'll take a look at how tubular eyes, unusual photoreceptors, and a surprising amount of glare may be the reason why owls can see perfectly well at night, but not during the day. Now I'm going to say the word eye a lot in this video, so I want to make sure we're on the same page about what exactly we mean by eye. We're talking specifically about the eyes of animals, the biological structures that allow organisms to see. Eyes come in all shapes and sizes in the natural world, but they all share a few features in common, including lenses that focus light onto light-sensitive cells, which are called photoreceptors. Photoreceptors are the parts of our eyes that respond to photons of light, allowing us to see. Humans have two types of photoreceptors, rods and cones. Rods are highly sensitive, meaning they respond to even dim amounts of light and can detect any movement in our visual field. They don't help us perceive color or details, though. That's what the cones are for. Cones need bright light to work properly and are responsible for the details and colors in our daytime vision. If you think about it, this makes sense. Having lots of rod cells would be great if you're a nocturnal hunter, because it means you can see really well in dim light. But it would be pretty terrible during the day unless you live somewhere with perpetually overcast skies. So it's important for nocturnal species like owls to have eyes that are packed full of rods and really low in cones. Sure enough, studies of living owls have found that their retinas contain around 90% rods and only 10% cones. This is not only significantly different from humans, who have roughly equal numbers of each type of photoreceptor, but also from other birds, whose retinas are dominated by cones, just like ours. For example, a pigeon retina has about 85% cones and only 15% rods. All that being said, though, having mostly rods isn't the only thing that makes owls' night vision so good. Another key adaptation is the size of their pupils. Pupils are the black holes in the center of our eyes that expand and contract, allowing more or less light to reach the photoreceptors in our retinas. The larger a pupil is, the more light can enter your eye, which is useful for seeing in the dark, but problematic in bright conditions. Owls' pupils are naturally quite large and can open even wider than those of most other birds. That means they can collect even more light for seeing in the dark. But it's a bit of a problem when it comes to seeing during the day. Even when an owl tries to reduce its pupils to compensate for bright light, the openings are still relatively large, meaning there's still way more light entering their eyes than is ideal. Too much light makes it difficult for the photoreceptors to do their job and can even damage them over time. So during the day, an owl's eye works over time to try to compensate for the excess brightness. It does this by scattering light around the pupil and within the eye itself, which helps reduce the overall intensity of light that reaches the retina. Unfortunately, this process doesn't work perfectly, and the result is that owls' daytime vision is often blurry and filled with glare, kind of like if you were trying to look at something through a sunbeam. In addition to these two adaptations, owls' eyes have a third feature that aids their night vision: their shape. Most animals, including birds, have round eyes. This shape is great for seeing in a wide field of view, which makes sense given that it allows us to see predators and prey approaching from almost any direction. But it's not great for seeing in the dark. You see, a round eye has a tough time focusing light when there isn't a lot of it. That's why your eyes pop wide open when you're looking at something in the dark. Your pupils are trying to collect as much light as possible. But a round eye can only do this to a certain extent. Beyond a certain brightness threshold, the eye just can't focus anymore. An owl eye, however, is shaped like a long tube. This means that even in dim light, it can still focus on objects in front of it. But because it's fixed in this position, an owl can't change the shape of its eye to compensate for brighter light. and that leads to glare. In fact, owl eyes are so tubular that they actually stick out from the sockets in their skulls, which may sound like it would be bad news for their vision. But the extra space created by this bulging is actually beneficial because it allows the lens of their eye to bend light around the edges of the retina, reducing the glare and improving the owl's ability to see clearly in low light. Basically, these tubular eyes are like binoculars for the darkness, allowing the owl to see really clearly at night, but limiting their ability to adjust to bright daylight. So owls have 3 features that make them amazing nocturnal hunters: eyes that are filled with light-sensitive rods, pupils that can widen to collect as much light as possible, and tubular eyes that focus light efficiently in low illumination. But these features come with trade-offs. Owls' eyes are amazing for seeing in the dark, but that's not when they experience glare. So when the sun is shining and the owls aren't, the glare interferes with their vision and keeps them from seeing as well. And while this might not be too problematic when it comes to hunting, it seems to affect their ability to forage. Studies have found that during the day, owls are much more likely to go hungry than at night, even though they spend about the same amount of time searching for food both day and night. On top of that, when researchers blinded one eye of captive snowy owls, they found that the owls were worse at spotting prey in the lighted binocular vision, which is probably why they spend so much time grooming their feathers. As you can see, the evolution of owls' eyes was a masterclass in trade-offs, resulting in some incredible adaptations for nocturnal life at the expense of daytime vision. Now, before you go thinking that maybe we should just evolve to have better nighttime vision ourselves, consider that humans do have a bit of an edge during the day. As far as we can tell, the only animal with better color vision than us is the mantis shrimp. And while no one has ever seen an owl during the day without its sunglasses, scientists believe that their tubular eyes may also give them a wider field of view than ours, although we do not know yet whether this is true for all species of owls or just diurnal ones. Either way, this trade-off between nocturnal superpowers and daytime struggles seems to be a small price to pay for being the undisputed champions of the night. Thank you for watching this episode. If you enjoyed learning about the amazing adaptations of owls, I know you'll love our podcast, which is all about the weird ways the world works. Every week we bring you new episodes on all sorts of science, technology, and culture topics. And thank you. See you later.